In this paper, we present Sketch2Scene, an efficient pipeline for automatically generating interactive 3D scenes from users' natural input prompt. Given a hand-drawn sketch of the scene and text prompt, a high-fidelity, interactive and playable 3D game scene is created instantly. The input user sketch and text prompt are fed into a control net that generates a 2D isometric reference image. Our scene understanding module then extracts the foreground object masks. The masks are utilized to generate the corresponding empty basemap using a unique in-painting model. The scene understanding module also computes the height map, texture splat map, and object instance pose. Finally, a procedural 3D scene generation module is employed to generate and render the 3D game scene. For the sketch conditional isometric image generation, we introduce an adapted control net for generating isometric images from text prompts and sketches. To tackle the challenges of training for such controllability with limited data, we proposed a novel approach called sketch-aware loss. The sketch-aware loss facilitates control nets training with a single ground truth image associated with diverse sketches generated through random category filtering, thereby enhancing its performance on flexible sketches. For generating 2D empty basemap of the terrain, we train a LoRa on SDXL in Paint to learn the distribution of the basemap and foreground masks. A customized training and inference mechanism is introduced which provides a well-controlled and accurate generation of the terrain, enhancing the overall quality of the 3D game scene. To overcome the absence of isometric basemap ground truth, we compile an in-painting dataset from 3 sources: 5,000 full isometric images, 4,000 manually filtered perspective images of empty terrains in-painted using Llama, and 1,000 pure texture images. Results show the generated isometric reference images in the middle, along with the in-painted basemaps on the right. In the user's sketch prompt, different colors represent different categories, including water, buildings, bridges, roads, and trees. After generating 2D isometric images, we perform compositional visual scene understanding technique to recover the necessary terrain parameters. Given an isometric 2D image, we apply the SOTA semantic segmentation algorithm, such as grounded segment anything, to separate the per-category foreground objects. After basemap in painting, we reconstruct a coarse, but watertight 3D terrain mesh using depth anything and Poisson reconstruction. We can then easily rotate the view to obtain a bird's-eye view of the terrain, and retrieve the height map and corresponding texture splat map using a combination of SAM and Osprey. For objects like buildings and other landmarks, the instance segmentation is applied to obtain the 2D reference image for each objects and estimate their pose within the 3D scene, which will be used for object retrieval or reconstruction at a later stage. We finally performs procedural 3D scene generation techniques for scene creation and rendering. In this work, we use the Unity game engine for building our 3D interactive environment, for Unity offers valuable optimization features for terrain, vegetation, and animation, ensuring optimized runtime performance. For larger objects, we use the segmented instance of the foreground object to perform object retrieval or 3D object generation. Now we demonstrate our Sketch2Scene can function as a game scene generator for video games, allowing players to freely explore the high-quality world with layouts that closely follow users' intention. And here are more example 3D scene generation results using our method. Thanks for watching.